Assalamualaikum. My name is Muhammad Afiq. Today I'm going to talk about report analog and digital modulation techniques. So, first of all, what is modulation? Modulation is a fundamental process in electronics and telecommunications that allows the transmission of information over various communication channels. Operation of varying amplitude, frequency, or phase of carrier signal accordingly with instantaneous amplitude of the message signal is called modulation. Modulation is simply means adding information to a carrier signal. Modulation also refers to the process of varying one or more parameters of a carrier waveform to encode information. It is crucial for transmitting signals efficiently over long distances. Overcoming noise and optimizing bandwidth utilization. The choice of modulating technique directly impacts the performance of communication system, affecting parameters such as signal quality, noise immunity, and spectral efficiency. Okay, so now we will talk about the types of modulation. So we have the continuous wave modulation and the pulse digital modulation. And throughout this presentation, I'll be explaining about the pulse digital modulation. I'll be talking about the digital modulation and the analog modulation. So, what is analog modulation? Analog modulation, it modifies a continuous carrier signal using an analog input. Example such as amplitude modulation (AM) and frequency modulation (FM). These techniques are primarily used in radio, television broadcasting, where two continuous waveforms are necessary to carry information. Then we have our digital modulation, which modifies a carrier signal using discrete digital. For example, amplitude shift keying (ASK) and phase shift keying (PSK). Digital modulation is widely used in modern communication systems such as mobile networks, Wi-Fi, and satellite communication due to its superior noise immunity and efficient bandwidth utilization. Okay, to start off, we will be explaining about AM, which is one of our types of analog modulation. So AM varies the amplitude of a carrier wave propagation proportional to the information signal while maintaining a constant frequency and phase, whereas the carrier amplitude is the message signal and is the carrier frequency. So this is the modulator circuits. So we have the modulator and the demodulator. For our modulator, we have the switching modulator. It utilizes a transistor or a diode-based modulator to mix the input signal with the carrier. Uh, the signal is passed through a bandpass filter of bandwidth to bit is centered at FC. For our demodulator, we use ambient detector as an example. So, ambient detector extracts the original signals from a modulated waveform. And then it detects the amplitude of the signal by producing a voltage that is proportional to the amplitude. It is usually used to detect message in an amplitude modulation system. Okay, so for in real world application, it's usually used in AM radio broadcasting for audio signal transmission. There are some advantages and disadvantages to it. So the advantages are simple implementation, efficient for long distance broadcasting, less modulation, signal power, and has a lower power design. And for the disadvantage, it is very susceptible to noise and it requires a large bandwidth. Next, we move to our second example of analog modulation, which is the FM. So the FM varies the frequency of the carrier signal based on the amplitude of the information signal. Frequency modulation (FM) is a communication technique that encodes information by altering the instantaneous frequency of a carrier wave. This method finds widespread application in various domains, including radio broadcasting, telecommunications, and signal processing. So for the modulator and demodulator circuit, for the modulator circuit, we use voltage control oscillator. So the performance of a voltage control oscillator is critical dependent on several key factors, including its tuning range, tuning gain, and phase noise. Low phase noise is highly desirable in VCO application. Both the tuning gain and the noise present in the control signal exert a significant influence on phase noise, with higher values of either generally leading to increased phase noise. As for the demodulator, we are using phase lock loop as an example, which also could be called as analog PIR. It consists of variable frequency oscillator and a phase detector in a feedback loop. The oscillator generates a periodic signal voltage output with frequency proportional to an applied voltage. The phase detector compares the phase, so the output with the phase of the periodic input reference, and it will be stabilized by the filter to adjust the oscillator's frequency to match the phase of output voltage to the input voltage. For our real world application, is used in FM radio broadcasting for high fidelity audio transmission. There are advantages, which are it's all transmitted power is effectively utilized, whereas in AM a significant portion is concentrated in the carrier, which carries no useful information. Additionally, FM offers superior noise reduction by increasing the frequency deviation and provides better protection against noise, particularly for lower modulating frequencies compared to AM. As for the disadvantages, FM reception is constrained to line of sight transmission, resulting in a smaller coverage area compared to AM. Then we move to the next session, which is the digital modulation, ASK. So the ASK is one of the digital modulation. ASK represents digital data using variation in the amplitude of carrier signal. Change amplitude with each single frequency constant that has a low bandwidth requirement and has very susceptible to interference. As for the modulator circuit, we are using multiplier modulator as an example. It uses a switch to toggle the carrier signal based on binary input. Firstly, the CT and DT combine rectifier with the bus taken from center tap of cycle coil of transformer. Then, for our demodulator circuit, we have our envelope demodulator, which employs an envelope detector and threshold decision circuit. Firstly, diode rectify bus, then current through forward bias diode that charge the capacitor. When diode reverse bias capacitor is discharged, smoothing output and DT is obtained. So, in real life application, is used in optical fiber communication, RFID system, RF system, home automation technology, industrial network devices, wireless base station, and tire pressure monitoring system. Has a lot of advantages, such as ASK offers high bandwidth efficiency as it requires less bandwidth compared to other modulation techniques. Its receiver design is simple as demodulation can be performed using a straightforward envelope detector. The disadvantage is highly susceptible to noise and signal fading as modulation is highly vulnerable to noise interference since noise directly affects signal amplitude, leading to degraded signal quality and reduced performance in noisy environment. Lastly, we have our last digital modulation, which is the PSK. So the PSK varies the phase of carrier signal according to digital data, where phase shift is corresponding to binary data. Okay, then we have our modulator circuit. I'm using route exchange method for one of the circuits, which the spectrum filters convert binary data to delta t that it combines with carrier and modulator. Then we can get the output. For the modulator circuit, coherent method implements a phase detector and decision logic, VPSK combined with carrier. Then it filters off high parts and threshold via decision differs. And lastly, it's more threshold with the ratio of 1 to 0. Okay, it's usually used in Wi-Fi, satellite communications, wireless LAN, RFID, and Bluetooth communication. So the advantages to this is it has high noise immunity, efficient bandwidth utilization. PSK efficiently transmit data over RF signal compared to other modulation types, making it a more power efficient option than ASK and FSK. The disadvantages: it requires complex synchronization techniques, PSK has lower bandwidth efficiency, and decoding binary data relies on estimating phase states, making detection and recovery algorithm highly complex. So to compare an analysis between the analog and the digital, so for our analog modulation, the bandwidth efficiency, the analog usually requires a larger bandwidth, and for the digital modulation, it uses multiple signals to occupy the same channel through techniques like multiplexing, advanced schemes such as the QAM and the PSK, which enables high data rates within the same bandwidth. Then, for the noise resistance of analog modulation, it is highly susceptible to noise. As external interference can distort the amplitude, frequency, or phase of the signal, affecting overall transmission quality. Then we have our digital modulation, which offers greater resistance to noise and signal degradation. Then for circuit complexity for analog, is that the circuitry for analog modulation is generally simpler as it involves only continuous waveform modulation and demodulation circuit, such as in AM and FM, which require fewer components. As for the digital modulation circuit, more complex due to the need for signal encoding, synchronization, and precise phase or frequency control. And lastly, our practical application for analog modulation is commonly used in traditional broadcasting such as AM and FM radio, television, and other legacy communication system. And for our digital modulation, it is widely used in modern wireless systems, including mobile communication, satellite transmission, Wi-Fi, RFID, and broadband network. To conclude our slide for today, so analog and digital modulation techniques, it serves specific roles in communication system, while analog modulation is widely used in traditional broadcasting. Digital modulation is preferred in modern wireless communication due to its noise resilience and efficiency bandwidth usage. Choosing the appropriate modulation technique depends on the application requirement, such as bandwidth constraint, tolerance, and circuit complexity. With decreasing demands for high-speed data transmission and efficient spectrum, digital modulation techniques are expected to dominate future communication systems. That's it for me. Thank you. Bye.